Hey guys, welcome to the Tech Career Booster channel. My name is Josh Ballardine, and today I want to talk to you about security. Yeah, this video is actually about how to keep your code safe. Better safe than sorry, and I want to apply that to secure your code today. So you're going to learn how to write code with security first mindset. I want to start talking about security for the beginners. For the ones who never wrote a piece of code before, uh, but you still have to think about security. Security mindset, that's what you have to keep in your mind first, before even learn how to code. And I want to bring today some concepts and some things you have to keep in mind before actually doing any piece of code. And I understand it's going to be a bit hard for you to try to figure out how you're going to do that if you never wrote a piece of code before. But if you keep the security in mind, if you keep all your things safe, you're going to be a better dev later. When you learn how to write code, when you learn how to do your stuff, if you keep these concepts in mind, you're going to be a better dev. And I know most of the course, they talk about security, but they do not emphasize that. And I want to emphasize that today. In these days where we have like security and data protection laws and everything, it's actually highlighted. Many people were talking about that. You have to keep that in mind when you are writing any piece of code, when you are writing any software. And the first thing I want to talk about, obviously, it's going to be security in your coding. When you start coding, you're going to think of security first. And when I say security, I would say security is made of many layers. We don't have 100% safe software. That does not exist. If you think something is 100% safe, that's not true. Nothing is 100% safe. You know, nothing is perfectly safe. Any software. But we can build many layers of security in the whole environment, including the software, which is going to make a very less likely for someone to actually get access to it. So we have some layers related to the environment, some layers related to where the software is hosted, and also we have some layers related to the code itself, some validations and things you have to have in place to keep your code and your software and your data safe. Mostly your client's data safe. It's going to be the last layer of security probably. So you have the user side layer, browser layer, network layer, hosting layer, and then you have your software layer of security. And when we are talking about your software layer security, one of the most important things is to actually implement input validations. What's those input validations? Basically, every single piece of software we're going to write these days, we're going to have interactions. And those interactions are going to require input. The user is going to be sending some data to you, some data to your system. And whatever is in that data, any field, even if it's a text field, it's just a name, whatever you are getting as a data, if it is files, the concern is like 3 times bigger than if it's just like a text or something. But even if it's just like a field, simple field like name or date of birth or comment, if you have like a blog and you have a comment underneath any post. So any input data you're going to have, you have to validate against many things, mostly against SQL injection or cross-site script injection. Any type of attack you can suffer, you have to validate all your inputs. I know we do have some frameworks these days. We do have some things in place when we are coding, which is going to apply that security for you. But you should not rely on that 100%. You should check if it's working. You should check if your inputs are not allowing anyone to actually send malicious code. And that's included in the best practices. We have many best practices when talking about software security, and that's going to lead us to the next topic, which is the secure coding practices. Those best practices, they are cataloged and they are available in that project called OWASP. It's impossible to talk about security without talking about OWASP. OWASP stands for Open Web Application Security Project, and basically it's a non-gov, not-for-profit organization which actually they catalog and any cybersecurity crime, and they also catalog how it's done, how they achieve that crime, how they do that, and they create best practices against that, or how you can protect your software against that. So they do have reports, and they do have many guides on how to apply that security. I definitely recommend you to Google that, OWASP. You're going to get to their website, and you're going to be able to see their recommendations in there. That's the first thing you should do when creating a piece of software. Even before starting, you should think of how you're going to organize the security of your software. When you're thinking of the architecture, you should be thinking of organizing that, organizing the security, or organizing how you're going to protect everything before starting. That's going to lead us to the first thing when we talk about data. The first thing you want to protect is your client's data. You don't want to lose that when it's stored. So we call that data at rest. What means data at rest? Data at rest means when data is stored somewhere. You want to keep that safe. You don't want anyone to have access to that. So you have to be careful who's going to have access to your database. Who is going to have access to the environment where the data is stored. If someone can store that, if a hacker can get to that environment, they can store that data at rest. And another layer where you should be careful is actually data in transit. What's data in transit? That's the traffic of the data between the user and your system. So when the data is going from a user to your system, you have to make sure no one else is going to intercept that. No one else is going to get the data in between you and your system, or between the user and your system. Or for example, probably most of you guys are using WhatsApp these days, and you can see WhatsApp says the messages are encrypted. What does that mean? That means if someone in your network get that data and try to read it, they're not going to be able to, because the data is encrypted. So in-transit data means that you should be careful on what you are doing with the data between the user, between where the data is generated and where the data should be stored. That's a concern as well. Some architects, they only care about data at rest, about grabbing the data and saving that and keep that safe. But some people, they don't actually have any concern on the transit when the data is going from the user to your database or to your server. And I'm not talking only about text data. It could be files, it could be photos, it could be videos, whatever it is you are storing, you have to keep that safe from the beginning to the end. And we just talk about encryption as well. And encryption is a way to actually keep your data safe, either at rest when you don't want anyone to read that. For example, passwords in a database, you can encrypt passwords in a database. But also it's a way to make sure your data is not going to be captured in the network. As I just mentioned, WhatsApp messages, they are encrypted between one user and the other. So if anyone gets that data in the network, that data is not going to be readable to anyone else other than the user who sent that and the user which is meant to read that. So let's say if you are in a Wi-Fi in a shopping mall, and that Wi-Fi, you send a WhatsApp message to someone, but someone is sniffing the network. Someone is listening to the network and capturing all messages in the Wi-Fi network. Obviously, someone is going to capture a message, but they're not going to be able to read that because it's encrypted. So encryption is a way to obfuscate the data so no one else can read other than the people who are supposed to read it. There are many ways of encryption these days. We have many algorithms of encryption. You have to be careful for which one you're going to use. As a dev, you're going to be using an algorithm to encrypt data. So you're going to encrypt that, and maybe you're going to decrypt that, maybe not, depends on what you're trying to achieve. But any algorithm you use, you have to make sure that's still safe. For example, MD5 was a very good and very used algorithm for encryption, but it was broken a few years ago. Someone actually was able to decrypt messages in MD5, and then it just became useless. It's not safe anymore. It used to be, but it's not. And we still find many databases using MD5 these days. I just have a case in a place where I should mention where, but I just have a case in a place where I was testifying that they're still using MD5 for the password encryption in their database. And they just got in a pen test. Just for you guys to understand, pen test is stands for penetration test. That's where a hacker trying to do an ethical hacking, and that's actually trying to get access to a system just to see the weakness of the system and report that to the owners. And I've seen one of those reports, and that report was saying the data was encrypted with MD5. So it means they had some concern about security and they had encryption, but the encryption was not good enough. So when we talk about security, we are not talking about one-off stuff. We are talking about forever concern. So you should be always looking at that. It's a continuous process. It's a continuous process to keep your system safe, but you have to think of that at the beginning. So encryption, it's used for storing passwords, storing sensitive data like bank details, or any sensitive data you want to store that you don't want someone else to read it. Someone who has access to the database should not be reading that information. You should encrypt that. And that's going to lead us to the next item, which is database security. What database security is? Database security is basically who is going to have access to your database. Sometimes we have like large organizations, and those large organizations have a system, you have a database, and you have the IT team. And the IT team usually have access to that database to do some stuff, to do some queries, to create some reports. But even people in that situation, we should be careful for who we're going to give access to. So database security means you need to know who's going to have access to your data and what's the level of access that people is going to be able to have. Also, you should be concerning which environment that database is stored, who has access to the whole environment. So basically every concern about your environment and your database and where your data is. And also we have authentication and authorization. What's authentication and what's authorization, and what's the difference between them? Authentication is basically saying who the user is. So who is this person? Who the user are. And once you identify that person and you know who they are, you need to understand what they have access to. That's authorization. So authentication means identifying someone, and authorization means understand which level of access this person have, which this person can have access to. So that's the difference between authentication and authorization. And that's the main thing that's easy to understand when all of you are very familiar with authenticated apps. Basically, any social media you have to authenticate yourself. So you're going to tell the social media who you are. You're going to use your username and password or something similar to username and password to actually get access to that. And that's authentication. It's going to let you in. So you got access to a system, but after getting access to a system, the system should keep everything else safe. So some people have some different levels of authorization. Usually we use ACLs to control that, or there are many other ways to actually control authorization and make sure the right people are going to have access to the right resource. So it's a continuous concern as well. You have to be continuously looking at that as a dev, and every piece of code you're gonna create, you should be checking what's the authorization for that. If you're creating a new screen, if you're creating a new table and database and saving data to that, whatever you're creating, you should be thinking of who should be able to do that. And most important, who should not be able to do that, who you should be blocking to do that stuff. Another important concept here is error handling. Why error handling is important? It's not really about security. The error itself, you're going to have errors in your application, and it's going to throw errors in the screen, and people are going to see things that are not working. But if you don't handle that properly, the errors, they can reveal some important information, and most people should not have access to that information. For example, some database errors, they're going to throw you the table name or the field name or things from the database which normal people should not have access to. Those errors, they are only for devs. Only you as a dev should be able to see that error and read that and understand what's going wrong with that. But if some hacker got that error, if some people with bad intentions, they got that error, they can have some information they didn't have before. So they can actually get the name of the table, they can get the name of the fields, which you should not be able to see. And on having that information, they can come up with some idea of bad code to actually get access to your system, or to do some SQL injection, or to be deleting your table. So you should be careful with your error handling. You should be careful with the way you actually treat your errors and the way you display that in the screens, or even the way you display that in your console. And another important thing, not really related to code, but related to yourself as a dev, is you should stay updated. You should keep yourself updated. You should use things like OWASP and other information research to actually keep yourself on top of what's going on in the world. Because it's always like, who is going to be smarter? If it's going to be the devs or the hackers, or the DevOps guys or the hackers, or whoever is actually creating things and whoever is trying to get unauthorized access to that. It's always like a fight between those people, and you should stay on top of that to not lose the battle. Because if you don't stay updated, you're going to lose the battle. You're going to make unsafe software. The hackers, they are continuously updated. And if you are not, you're going to lose it. It's simple as that. So you must be updated. You must be reading and be concerned about security all the time. Obviously, you're not going to be paranoid of that. You should not be paranoid. But you should be studying and reading important things every week, every month, and keep on top of what's going on in the security world, especially on top of your preferred language. Let's say if you're using JavaScript, what's going on in JavaScript world. If you are using PHP, Python, whatever you're using, what's going on in that world regards the security. Also, the database you are using, if you're using a SQL database, what's going on in that database? Do they have a new version of that database? What was the security issues with the previous version? What you can actually avoid in the next piece of code you're going to write? Is anything unsafe in your current app? You should be checking. You should be even having automated code to read your code. There are some softwares out there which read your code looking for security concerns, looking for security holes, and they're going to help you. And if we get more generally speaking about online security, you also should be concerning about a few things. For example, password strength and management. What do you do with your passwords? Let's say your social media passwords. How do you store them? Do you have all of them in mind? Do you use the same password for everything? You should not, definitely. The recommendation is having a different password for anything. But if you have a different password, how are you going to keep them in mind? It's very hard to remember them. So it comes to password management. How are you going to manage your passwords? We have some tools to manage the passwords. You should be very careful which tool you're going to use, because if the tool is unsafe, all your passwords are unsafe. Some tools are free, some of them are paid. Some of them, they have like a free tier, and then after some things you have to pay. But be careful with which tool you're going to use to manage your passwords. And definitely don't use the same password for everything. You wouldn't use your bank password for your social network. You wouldn't put your Commonwealth Bank on Facebook or on Instagram. Doesn't make any sense. You know, if someone gets your Instagram password, they can get access to your bank account. So there's no meaning and no chance for you to do that. Don't do that. And some people think, it's not for me. No one's going to be interested in my life. I'm so boring. Why someone's going to be interested in me? Sometimes it's not you, but sometimes it's what you can have access to. Let's say people are not going to be interested in you, but they're going to be interested in your company. So they're going to use you as a stepstone to actually get to your company, to actually get to your company system. So they're going to get your password. And if you use the same password for Instagram and for your CRM system in your company, they're going to like hack your network at your home, grab your Instagram password, and try that on your company's CRM. And voila, they got access to it. So don't be fooled and don't think people are not interested in me. I don't have anything to hide, or I don't have anything people would be looking for. Yes, they are. There are tons of cyber crimes every day, and they usually tackle the less strength side or the most weak side, which is the user. As we just mentioned, for the systems, we have the devs concerning about security, and we have many layers of security in the system. So it's a bit harder to actually get access to a system by a failure in the system itself. It's a way easier to actually get a failure in the user side, because the users, they are less concerned about security. Most people are not concerned about security at all. And they have like very short passwords. They have just number passwords. They don't store the passwords anywhere, or they put that in a piece of paper on top of their desk. You know, it's a very, very weak side. The user is the weakest side in that all security stuff. So keep your passwords big enough and manage them properly. Also, it's going to lead to two-factor authentication. Don't have only password. You should have your password plus a second factor of authentication. It could be your email, depends on the system. Usually the system will allow you to choose between one and another. Some systems, they define the second factor for you. It's going to be an SMS message. It's going to be the Google Authenticator. You know, there's an app you put in your phone called Authenticator that has a different key which changes every minute. So they use that as a second factor to prove you is you. And always keep that enabled. Obviously, you have to get access to a system first, and then you have to enable that later. Some systems, they are not allowing you to disable that anymore, but some systems still let you use only password. If your systems are letting you use only password, but you do have the option to enable two-factor authentication, keep that enabled. Don't be fooled thinking it's not needed. It is needed. So enable two-factor authentication. It's never too much to say keep safe in browsing habits, like don't download things you don't know what it is, don't click in links in our emails you don't know what the link is for, or don't be fooled with phishing emails, don't fall in that. If someone send you an email and you have some money to earn, or so they want your bank account details to give you money, obviously no one's going to give you money. Don't be fooled. Don't click in links. Don't fill up forms. Don't give your details away. Doesn't make sense. If something looks too good, it's not good. If something looks, that's for me, you win the lotto, you win whatever, don't be fooled, man. If you didn't do anything for that, why someone's going to give you that? So don't fall that. And last but not least, always check for secure connections, the HTTPS. We just talked about encryption. I spoke about that in another video, what HTTPS means. It is the secure connection over HTTP. And you should always check if you are using HTTPS, if your browser connection, whatever you're using for banking, for social media, for whatever, if it has the locker in the top, if it is a secure connection. If it's not, it's very easy for someone to intercept your communication and grab the details you are sending to wherever. So even if you're just filling up a form in a website, if the website is not using HTTPS, if this connection is not secure, you're going to be at risk to actually give your data away to someone else in the network. That's it, guys. That's what I had for you today. I hope you enjoyed this video. If you have any question, let me know in the comments below. I'm pretty happy to actually respond any questions you guys may have, and that can be helpful to someone else as well. So just leave your comments below with any question or any security concern you have. If you agree, let me know. If you disagree, let me know as well. And yep, share this video with someone who needs to know it too. Don't forget to leave your thumbs up. See you guys next time.